Hey guys, welcome back to this lecture. Um, so let's see what we learned. Let's revise a little bit about what we learned in the last lectures. So last time we reviewed about Bernoulli's equation. We did some of the examples. We learned about some of the concept, right? You guys remember what the Bernoulli's equation looks like? So Bernoulli's equation is, let's look at this and we'll go back to the example. So P1 plus, or P pressure plus half rho, which is the density of the fluid, times V1, which is the speed of the fluid, and then the square of that quantity at point 1, plus rho Z H, right, or the height of that fluid, or Y1 here in this case, okay? And that is supposed to be constant. So review questions, we also looked at this diagram here. So the water was flowing through, this tube here, and then this tube has a different diameter and is also at a different height. So there are three different points. Point A is here, point B is here, point C is here, and then after using our volume flow rate, and then which is or the continuity equation, and then Bernoulli's equation, we came up with the answer that pressure at point C is the highest pressure we have, and then the second highest one is the pressure at the point B, and then the pressure at point A is the least one. Okay, so that was what we learned. Alright, so today we are starting a new chapter, guys. Oops, sorry about that. New chapter, so chapter 14 on oscillations. Alright, before we kind of go into this topic here listed here, when was the last time you have heard about this word oscillations? So take a moment. Where have you heard about this? Anywhere? Like maybe in your day-to-day life, maybe maybe you have heard it in different different subject, or like different textbook, or somewhere you must have heard about this. So please take a moment, reflect on it. Oscillation. Try to give your mind, try to bring all the information you have heard about oscillations. Okay, so take a couple of seconds. Okay, so we are going to look at what this oscillation really means, or oscillatory motion. We are also going to look at what equilibrium position means, what restoring force means. But before we go to that, you must have heard about something. must have heard about about something about the spring and mass system, okay? So you must have done something about it in 201, or you must have heard about it. So let's see again. Let's do a demo here. Alright guys, so I have a spring here. I have actually two different springs here. One is like it's harder to pull. So this is harder to stretch, so this is stiffer and this is very soft, okay? So let's just see. Alright, so yeah, that is, we can see that that's kind of, you know, moving up and down, but not to a larger distance. Okay, let us do this one. This one I gotta take out these masses. This is very soft, okay? So let me try doing that. Let us start with little mass and then we can add more glue. Okay, so this one right here is softest spring I have. This is a 20 gram, this is 50, so 70 gram total mass here, okay? So this is spring here. Oh, look at this, even with this little mass. Okay, we'll add a little more mass and let's see. This is another 20 gram, so that makes a 90 gram here. Oh, look at this. Further down. Oops. Further down. Okay, so it's going down, coming up, going down, coming up, going down, coming up. So this kind of a repetitive motion is called the oscillatory motion, okay? So let us see a couple of things. So we finished the demo here. What do you remember about the force provided by the spring from this? What do you remember the force provided by this spring here? So take a moment if you remember anything about the force provided by this spring. Remember we did that, you know, force provided by this spring, you know, in 201. So what could be the force Fs equal to what? Do you guys remember anything? Since we had this, you know, spring vertical, so let us say spring force in a y direction equal to what? Okay. You may have done the equation where you may have seen what F is equal to minus kx, okay? And then maybe this x-axis was, so the spring was in a horizontal direction. So maybe you may have written Fsx or something like that, right? So here really Fsy equal to what? So if you remember anything about the spring force, you know, from 201, then the spring force is really given as what? Spring force Fs x equal to minus k times x. For if we decide to use it for, you know, vertical spring, instead of x we should have y, right? So minus ky, where k is spring constant, right? K is spring constant and y is change in length. Right? Or you may have looked at something like elongation or stretch or something like that, okay? Now, so describe how the motion of the mass, how does the position, let's describe the motion of this mass. That's mass of this this mass on this spring. Okay, so how can we describe the mass? How does the position changes as time goes? So let's say when we haven't stretched it, it's like this, right? So this is not, there is nothing, this is the original length of the spring. The moment we put this mass, what happens? Oh, it got elongated, right? So it is small. Now because we are hanging a mass, and the important thing is this mass is not moving, okay? So we want it to be stationary here. Now this change in a length, this change here, right? There is this change in a length. Now if we consider this length here, or this position here, first of all, this position of this mass when it is in this spring and when it's not moving, this is called equilibrium position of the object. Okay, so here we could, you know, draw a free body diagram, and then we could write equilibrium position as up to here. Okay, so this whole length here is what we have, the original length. Now that is this, is it changing with time here if I leave it like this? No, it is not changing with time. It's sitting stationary. I mean, it may not be looking very stationary because my hand is shaking a little bit, but stationary. Okay, now how does the position change with time? So to observe that you know, change in position with time, so let's set this into periodic motion, meaning the motion that repeats itself over time. So repetition is, look at this. Oh, look at this, going down, coming up, going down, coming up, going down, coming up, going down, coming up, right? So the position is changing, is going down, it's coming up, going down, coming up, about that equilibrium position. Okay, so whenever it's going down and it reaches the maximum, so if we start somewhere here at 0, right, you consider this 0, what happens? It's like this. It goes all the way down. As the time increases, it's going down, right? Meaning the, you know, position is changing, getting maximum, and it's coming back. It reaches to that equilibrium position, and then again it goes back like this with time. Okay, so it's periodic here. It is repeating, and it's not happening just one time, but it is happening multiple times, doing the same thing over and over in a, you know, after a period of time. Okay. So what do you think about how does the velocity change with time for this object? Let's think about that. How does the velocity change? We know the position is changing as we go away from origin. The, you know, position, the amplitude position is, this is increasing as we come back, and it gets maximum, and then as we come back it gets smaller, gets smaller, and then it goes back again, increasing, meaning the change is again there, gets, you know, maximum change, and then again goes back. Okay, so we kind of have some idea about this change in position with time. This maximum distance from, this is the equilibrium length right here, this maximum distance that this mass is going to reach after it is in motion is called amplitude. Okay, so that is called amplitude and represented by capital A. Okay, now how does the velocity change with time? What could you say about the velocity? Alright, what do you think happened to the energy as this object is moving up and down? What do you think is happening potential energy? To potential energy. If it's like this, it's at a stationary, right? So it must have a potential energy. Once it's in motion, it has a kinetic energy, but it's going down. Momentarily, it's going to stop, almost like momentarily, instantly stop there, get maximum, again come back and go back, and then again go down. Okay, so there must be change of, you know, transformation of potential to kinetic, kinetic to potential energy, right? Okay. So the force associated with this spring here is the force which tries to bring this mass back to its original length or equilibrium position is called restoring force. Okay, so few words here I'm going to write it over here. Restoring force. And then we could, for a spring, we could say, you know, Fs. Okay, restoring force. If you know, if you had another object, you just could say just F something. Okay, here, restoring force F. And then we look at the equilibrium position. We are talking about the restoring force. We also look at what the amplitude is. Amplitude is nothing but it's really the position. Okay, that's the important. Amplitude is really the, you know, the longest or the maximum possible position that the, you know, mass could reach. Okay, all right. So what other examples of motion can you think of when we talk about periodic motion? In any other example? So take a moment to reflect on that. Have you looked at anything that's kind of doing like this, repeating over like this? Or maybe going like this, going this way and then coming back like that? Anything? What do you think about the swing, you know? Where you're younger, maybe you would go to the park and then sit there and then, you know, sit in a swing and then play. Say, swing, right? It's also, it goes, when the person sits there, it goes, it comes back, goes, comes back. So that's also another example, right? That also has a periodic motion. So there are varieties of other examples. People who go for bungee jumping, right? And people jump there and then the rope is going to just move them, you know, take them down and up and down. So that's also another example. So there are varieties of example in a real life, right? So you guys can maybe make a list of more items, okay? All right, so is this topic clear here? Oscillation, meaning, or oscillatory motion, meaning motion that repeats itself over time. Okay, alright guys, so in the next video we are going to talk about how to model some periodic motion or repetitive motion. Okay.